Hi, welcome to Code Cadence. I am your host, Sam. This tutorial is part of our Data Structures and Algorithms course. After watching these tutorials, the concept of different data structures and algorithms will be crystal clear and easy for you to understand. First, we will dive into data structures. In this tutorial, we will learn what are data structures, the different types of data structures, for example, primitive data structures, which are the foundation of more complex abstract data structures. Then we will learn abstract data structures and its build using primitive data structures. We will also learn linear versus nonlinear data structures. We will learn how primitive data structures help build abstract data structures and real-world application of data structures. What are data structures? Data structures are What are data structures? In computer science, a data structure is a specialized format for organizing, managing, and storing data efficiently. It determines how data is structured, accessed, and manipulated. We will see real-world examples to better understand data structures without keeping computers in mind. We can take the supermarket analogy. Imagine you are in a supermarket managing different sections of products. You need to organize and retrieve items efficiently for customers. Let's see how different data structures relate to this real-world scenario. Now we will try to understand the concept of an array with a scenario of grocery shelves with fixed sections. Think of a supermarket shelf divided into fixed sections. Each section contains a specific types of products. For example, milk, bread, eggs, etc. You can quickly grab an item if you know its exact location. However, if you want to add a new item in the middle, you might have to rearrange everything to make space. For example, the dairy section has fixed spots for milk, yogurt, butter. If you want to add cheese in the middle, you will need to rearrange items, just like shifting elements in an array. So what are the real-world takeoffs? Arrays are good when you need quick access to items, but they are less flexible when modifying the structures, for example, adding or removing items in the middle. Now we are going to understand the concept of a linked list with the scenario of shopping cart. Imagine a shopping cart where each item is linked to the next. When you add an item, you don't have to rearrange anything. Just place it in the cart. If you remove an item, the cart still works fine without affecting the others. But if you need to find an item, you might need to look through the whole cart. For example, you have added apple, bread, milk in order. If you remove bread, the cart still has apples and then milk. So linked lists are flexible but take longer to search through. Now we are going to understand the concept of a stack using the scenario of plates stacked at a buffet. Think of a stack of plates at a buffet. You take the top plate first, which follows the last in, first out LIFO principle. If you need a plate from the bottom, you must remove all the plates above it first. For example, the last plate placed on the pile is the first one placed on the table. Stacks work best for tasks where you undo the last action first, like a stack of trays or undoing writing in a notebook. Now we are going to understand the concept of a queue using the scenario of Superstore where people are waiting in the line at checkout. Think of customers standing in the line at checkout. the first person in the line is served first, which follows the first in, first out FIFO principle. You cannot skip to someone in the middle. Everyone waits their turn. For example, if Alice arrives before Bob, she gets served first. Queues are used for situations where order matters, like waiting in line at a superstore or a bus stop. Now we are going to understand the concept of a tree using the scenario of supermarket aisle categories. Think of how products are organized in a supermarket. The main category is the entire supermarket itself. Inside you have sections like dairy, vegetables, snacks. Inside those sections you have subcategories. For example, dairy contains milk, cheese, yogurt. To find a specific cheese, you need to follow supermarket first, then the dairy section, then you need to go to the cheese aisle, then pick up your mozzarella cheese. Trees help in hierarchical organization, making searches faster, like in store layouts, family trees, or company structures. Data structures exist all around us, even outside computers. The way we organize and access information determines the best structure to use. Choosing the right organization method makes searching, adding, and removing items more efficient. Now we will see why are data structures important. It is important for many reasons. For example, efficient data management helps in organizing and accessing data efficiently. It helps in optimizing performance. It enables faster searching, sorting, and data manipulation. This is how it helps optimizing the performance of a system. For better algorithm implementation, algorithms rely on data structures for optimal execution. Memory utilization. It helps in managing memory effectively and avoiding wastage. It also helps you in job interviews, competitive programming, and to be a better programmer. Data structures are broadly categorized into two types: primitive data structure, abstract or non-primitive data structure. Now we will see an overview of different data structures. First, we have main two types, primitive and non-primitive data structures. Non-primitive data structures are also known as abstract data structures. Under the primitive data structures, we have integer, float, character, Boolean data types. There are two main types under non-primitive data structures, which are linear and nonlinear data structures. Under the linear data structures, we have array, stack, queue, linked list. On the other hand, nonlinear data structures are tree, graph, hash table. Now we will see the difference between linear and nonlinear data structure. This image categorizes data structures into linear and nonlinear data structures. Linear data structures such as array, linked list, stack, queue, and nonlinear data structures such as trees, graph, and heaps. It visually represents how elements are organized, accessed, and manipulated in each structure, highlighting differences in order and connectivity. So let's see what is a linear data structure. A linear data structure is a type of data structure that stores the data linearly or sequentially. In the linear data structure, data is organized in such a way that one element is adjacent to its previous and the next element. It includes the data at a single level such that we can traverse all data into a single run. On the other hand, a linear data structure is one where data are not arranged sequentially, but rather in a hierarchical or interconnected manner, allowing for complex relationships between elements, unlike linear data structure like arrays or linked lists. Hash tables are a data structure that can be implemented as a linear or nonlinear data structure. Often they are implemented as a linear data structure. Hash tables are used to map keys to values. If you had a list of items, for example, a hash table might be used to identify a person's phone number using their name. Now we are going to learn primitive data structures. These are the fundamental building blocks that directly operate upon machine-level instructions. They represent single value and they are typically supported natively by programming languages. Example of primitive data structures. Integer, a number that is not a fraction, it's a whole number instead. Float or double. A fractional number or a number with a decimal point is commonly represented as float in programming languages. Character. A character in computing refers to a basic unit of information that represents a letter, number, symbol, or control code. It can be a single alphanumeric character like A, or a special character like $, pound sign, or and symbol. A Boolean is a data type that can only hold one of two values, either true or false. It used to represent logical conditions and decisions in programming languages and digital circuits. Pointers. In computing, a pointer is a variable that stores the memory address of another variable, allowing you to directly access and manipulate data stored at location. Primitive data structures serve as the foundation for more complex data structures. Primitive data structures serve as the foundation for building more complex data structures. Here are some examples. Integer. It stores whole number. For example, here we have a variable called age, which stores a value which is 25, and the data type of this variable is integer. Integer used in counters, loops, and indexing arrays. For example, we can see an array where an integer data type is used. Floating point stores decimal numbers. For example, here we can see a variable called pi, which holds the value of a pi. And the data type of this variable is float. Float used in scientific computation, financial applications, and measurements. For example, calculating the average temperature or banking rates. Character stores a single character. Here in the example, we have a variable called grade, which stores a character A, and the data type of this variable is character. Character used in string manipulation and text processing. For example, A, B, C, these letters can be used to represent different marking in the grading system. Boolean. It stores either true or false, these sort of values. Here in this example, we have a variable called isActive, which holds the value true, and the data type of this isActive variable is Boolean. For short, we can say bool. Boolean type used in conditional checks and decision making, for example, if-else statements. It helps in checking logging status, sensor off or on status. Pointers stores memory address of other variables. Here in the example, the code snippet demonstrates the concept of pointers in C++. Here, num is an integer variable set to 10, and ptr is a pointer that stores the memory address of num. This type of data used in dynamic memory allocation and linked lists, for example, managing nodes in a linked list. Here we will see how primitive data structures serve as the foundation of more complex data structures. For example, int is a primitive data type, which can be used in more complex data structures. For example, arrays, linked lists, and trees. Float and double can be used in graphs, weights, scientific computing. Character can be used in strings and text processing. Boolean type can be used in conditional statements, decision trees. Pointers can be used in dynamic memory allocation and linked lists. Now we are going to learn about abstract data structure. Abstract data structures are complex data structures built using primitive data types. They provide more efficient ways to manage and process data. Types of abstract data structures. First, we will learn about linear data structures. As we already know that abstract data structures are, for example, linear data structures and nonlinear data structures. So now we will learn about linear data structures. These structures arrange elements sequentially. For example, array a fixed size collection of similar data elements stored in a contiguous memory. A linked list, a dynamic collection of nodes where each node points to the next. Stack, a last in, first out structure used in recursion and expression evaluation. Queue, a first in, first out structure used in scheduling process. Nonlinear abstract data structures. These structures arrange elements in hierarchical or network-based relationships. Tree, a hierarchical structure where each node has a parent-child relationship, as you can see in the chart. Graph, a set of nodes connected by edges useful for representing networks. Hash table uses a key value pair structure to allow fast lookups. Now we are going to learn the key difference between primitive and abstract data structures. We will learn the difference by their features. Complexity-wise, primitive data structures are more simpler than the abstract data structures, which are more complex. In data representation, primitive data structure stores single values, where abstract data structure stores multiple values in structured forms. Memory management, primitive data structure directly managed by the systems. An abstract data structure requires custom memory handling. In operations, primitive data structures does the basic operation like arithmetic and logic, where abstract data structures does advanced operations like searching, sorting, and traversal. Here we can see some examples of primitive data structures. For example, integer, float, character, boolean, as we already know from the previous slides. And the abstract data structures are array, linked list, stack, queue, tree, graph. In conclusion, both primitive and abstract data structures play an essential role in programming. Primitive types form the foundation, while abstract data structures allow efficient data management and problem solving. Choosing the right data structure depends on the problem requirements, memory constraints, and performance consideration. Thank you for investing your time in this tutorial. If you like this tutorial, please subscribe, like, and share this video so that when I upload my next video, you will have it first on your timeline and it will help me to grow my channel. Thank you very much.